Hello, in this video I will be showing how to find a root locus of a function in Matlab. This is for EEC 441 control systems for Dr. Gao's class in the Fenn College of Engineering at Cleveland State University. First thing I would do is open up Matlab. I'm doing this in Mac OS, but you can also do this in Windows. The steps are exactly the same. And these we'll use later on for explanation of the root locus and what we can do with it. So the first step is I will just put in an arbitrary equation. So with the numerator, and I'm just going to do 1, 7, 0, and these are just numbers I'm showing. Oh, I forgot to put in an equal sign, so numerator equals 1, 7, 0. And now I'll do the same thing for denominator. So denominator equals, and then see, put a higher order than the denominator. And then I can identify a function called sys, and that it's going to equal the transfer function of the numerator over denominator. And Matlab puts that out right there. And so to find the root locus of this, all I do is type in r locus and then of the system, which I have named sys, S-Y-S, and hit enter. And there we go. That shows the root locus of the system. Now I can make the graph a little bit nicer by typing axis and equal. That's going to just make the axes equal to each other, the spacing. So it gives the circle nice and round. And we know that the damping ratios are going to be affected by the pole locations. This handout that we were given, the second order transfer functions, it really mattered the angle, the theta, because if the damping ratio was, let's say, below, if the poles are below the 45-degree line right here, then the damping ratio will be less than 0.7. So for this, to make it easier for us to pick pole location, we can type in grid. And what this does is it puts a grid in here, so we can easily put in pole locations, and then it marks down. And then from this we can select a pole location, and we do this simply by clicking. Let's say we want it below the let's say I want one right here. So I click right there. Oops, I skipped a step. What I have to do is type in K poles equals r loc find, and then of the system. So we're going to find the root locus of the poles at a certain location. And I hit enter, and it's right here. It says select a point from the graphics window. So I select a point I just clicked on, and what it does, it shows a selected point, gives me the K, and names off the poles. Now I think it's important to note that we can also go a step further with this, and if we wanted to see, let's say, the Bode plot, we can also use system in, system out tool. That's SISO TOOL. It's also an important tool that we can use, and in evaluating like root locus and Bode plot, the frequencies. So I would have to import the data of the transfer function and it comes up right here. And this is really nice because it shows the different things that are going to change as I change one value. Let's say I move the pole up and down. It immediately shows the Bode editor, and I can even move the Bode up and down. I can also, for the closed loop and for the open loop. So it shows me where the poles are going to change as I change the Bode plot, and the frequency also. So this is all very important. And thank you for watching, and I hope you enjoyed.